So press the dimension tool. Press D or press the dimension tool. So I press D to select dimension tool. Then from here, let's drag this out. Click on this point. Let's set it to 25. Just put 25 in the box and enter. So you see it kind of changed the size. I could zoom out by scrolling out using the scroll button on my mouse. I could drag this out, position however I want it. Then again, using the dimension tool. The dimension tool is still selected in this case. I haven't taken it off, so it's still there. I click on this side. You see when I click on this side, the line changes to orange. It means that that's what I'm correctly selecting. So drag this out, enter the value 4. Again, you see the shape changes. In case yours changes and it doesn't look like what we started with, you can move the points that are still blue. You can move them around. Let me show you an example. So this, let's say this now looks wider than how I want it to be. I could just bring it down. You see now that is also moving, it's not moving the way I want it. And I can move this. I can move this around. See, I can move the points that are still blue. The points that are still blue can be moved around. Okay. So now that I have that, I go back to my press D again on the keyboard. Click this side. Enter 6 and enter. Click this side. Enter 3. Click this side. Enter 1. So this I'm setting, all these dimensions are in inches. All the dimensions so far in inches. Inches is the default system it goes to here. You could change the dimension though to metric system, but inches is the default and we're just leaving it like that. So click on this side again, change to 6. Change to 6. Then you see these 2 lines are still blue, means that they're not fully, you see all the lines that are black means that they are fully defined, means that they have a position. They have a position and they have a size. Every single line that is black means it has a position and has a size. The ones that are not blue here means they don't have a position and a size. So this now, I click on this. See first, let me do it again. I click on this side, click on this line here, then click on this line and change that to 3. See now this one has changed to blue. This is fully defined. Only one that is left undefined is this one. So I could click on this. Click on this one first, then I click on the side here. That allows me to set an angular dimension. So I'll enter 135 here. Now everything is black, means that we fully defined the sketch. Okay? I'm assuming everyone is following along. Then you can just click on extrude here, the extrude boss or base, or press Shift E. So click on that. So in this field here, we set the depth to 8 inches. We set 8 and enter. Okay. So I can use my right mouse button to rotate to see what I just did. So that's what I just did. Setting it 8. So let's just put 1. You see what it changes to, changes the size. So I'm setting it to 8 here. That's how wide I want this. We've drawn one part we've drawn one part. So this is fine now. Click OK. That's what we want. Then we could click on this face, or we could just click on the rotation cube here. Click right on the rotation cube. Click right here. So now we have this face, right? So if you draw sketches on 2D planes. So now I want to draw another sketch now, but I want to draw the sketch on this face. So we use this face now as our plane. So click on the face. It changes to orange again. I've selected the plane. On the top left, there's a sketch button. So click sketch. So now we selected the sketch again, show constraint. We want to see what kind of constraints are on each object we draw. So now we draw 2 corner rectangles. So we'll go to the rectangle tool. But this time, instead of selecting the center rectangle, select the corner rectangle. The corner rectangle is the one on the top, or you could just press G key. So I selected the corner rectangle. So I'll start drawing. You see now, as I get closer to this edge, it changes to orange, and that icon appears beside it. So click from there, drag out. Again, it doesn't matter how it looks like. We just want to get the rough shape out. Draw a second one. So we're drawing like a cross here. a simple cross. So if everyone has gotten this cross, the next thing now is also to dimension it again, to dimension the line out again. So we could press the D key on the keyboard. Press the D key on the keyboard to dimension it. Let's start with the first rectangle we drew. You can notice that the line on the bottom is black, meaning that it has a position. It has a position, it has a size. So we draw, let's set this size here first, the spacing between two of them. Set this to 2. Set this height here to 4. All right, you see two of the lines are dark, are black now, but these two are blue because they don't have a position. They might have a side, but don't have a position. So if we click on this edge here, and click on this edge, we click this edge and click that edge, we can set the spacing there. Let's set the spacing here to 3. So now see the line is black, means the line is fully defined. We finished defining this line. Then now the second one, let's do this other line. We click here, change to 1.5. Click on this line, change to 5. Change to 5. Then now both this line has dimension, but it has no position. So if we reference these edges here to create a position on any of the other edges here, let's reference this edge and let's say from here to here, we'll set it to 1.5. Then now we can set from here to here as 1.5 as well. 1.5. So now the line is black now. It means we fully define this line. So select the circle tool. The circle tool is on the top here. Click on the circle tool, or you could just press C. Press C, drag out. Doesn't matter where you click the circle, just put it anywhere. So I'm going to just drag the circle. Let me start. Drag the circle out, just a random position. So now the circle, we need a position on the side. So click D again to set the dimension. Set this circle to 2. Now that we have the circle as 2, we click on the circle again. Now click on click on this edge here, and we set that to 1. Then set this, we've set the position, we've set this, we set the vertical position, let's set the horizontal position. So I want to set this to 3. Okay, so now the circle is black now. So it means we fully defined the circle. So the next step would be to take this part. We're going to cut this out from the main part. So we'll be cutting this out. So to cut this out, again, we click the extrude on the top left. But this time, you see, instead of click here is add. Instead of adding, we want to remove. We want to remove material. We're not adding material. We want to remove the material. So remove. So you see here, it said blind. It means that, okay, this is how far I want to go. We could change this to like 5. You see, it went deeper. Change it to 10. It goes deeper. Or we could just come here and select true all. We could click on this drop down menu here and select true all. Then we don't have to set any dimension. Then we select true all. You see, it cuts that through the entire block. Then click OK. Okay, now that we have this, a few more touches.
Sure that people are following, please.
Okay. Sorry.
I just feel like there are some people on here who haven't designed before.
Yes, I assume that, but I'm assuming everyone is following because no one has said they're not following.
Is everyone following?
Hello, is anyone following? Okay.
Okay, so somebody said not following. Another person said, I got lost, so I decided to just watch. Is it okay to repeat some of the steps?
So if you could tell me where you're lost from, I can repeat the step. Okay, you could use, yeah, you could use the document for recap. But if I could clarify some of the places you got lost or got confused, like so the deletes, oh, where we took out the material. Okay, so I won't do that. That was okay. So go back to, okay. So if you've gotten to this point, also, okay, if you're lost, let me just show you something quickly. If you're lost, if you want to just see all the steps and maybe have the what I'm working with, and if you don't want to design it, you just want to look at it, you could come to Onshape here and search in Onshape. Come to the top of Onshape here, search in Onshape and just search Vice. I named it this way so it'll be easy to find, Stem Hub. So Vice Stem Hub, I'll post that in the comment section. Search that in Onshape. If you search this in Onshape, you should be able to find the project I made. So you should just search everywhere. Search everywhere. Then once you have that, click on the project. Then you can view each part. You can view each part that's been made. Each of the final part. I've made the final part so you can see. Okay. Then if you're confused, you could also just go back to the sketch, like edit, and see where we are. Does that help? For someone that started late, if you're behind on a part, leave that part. We're making four parts. So if you're behind on one part, just leave this part, and the next one you do the next one. Okay. So yeah, if you have that, you could just use that and start working from there. Okay. So go back here. So after drawing this out, I click on extrude here on the top, extrude on the top. Then I click on remove. So when I want to remove now, I want to select true all. On the top here, you see right here, I want to click on this. It's where it says blind. I want to click on that and select true all. So what that does now is that it just takes the material from this entire body using the sketch. Using the sketch. Okay. So now that we have this, we can add one more feature to it. So I'm going to accept this. This is what I want. So I want to fillet this edge. I want to make this edge round. Sharp edges in design, sharp edges are not good. I try to avoid sharp edges. Sharp edges are not good. Try to avoid it as much as you can. Okay, so we click on this edge here, or we could just first click here, the top side. Let me slowly use the orientation cube here to position it like this so you can see. The orientation cube is over here. Click on the orientation cube, click on this dot here in the orientation cube. Then once you have it in this position, you can click the front, you can click the side, you can click on this top edge here. Once you have this position, on the top side here, you see there's like an object here that has fillet, this object here. With the rounded corner, click on it. Click fillet here. Select these two edges. You see, once I selected, those two edges came up here. Then I can select the value I want. How big should this rounded edge be? So I'll select 3 in this case. So is everyone following up to this point? Is anyone up to this point, please? Someone that hasn't designed before, is anyone up to this point? Someone that hasn't designed before, is anyone up to this point?
There are no beginners materials. That's why that material was created, so that people can, if they're lost, they can go back to the material and look at it.
Okay. So guys, you're following. Have you designed before? Okay. So you click on the fillet, then choose the 2 edges there, then set the number here to 3. Right, then click OK. So now that we have this done, we could come here and change the appearance. Usually you could change the appearance, you could change the material. You can also, the reason to change the appearance is that when you're combining things together, it'll be easy to identify what it is. You can assign material. A good reason to assign the material is if you want to calculate the weight of what you're making. Okay, is this too big? Is it too heavy? Do I have to design it lighter? Can I remove material somewhere? Something like that. You assign the material together, assign the properties here to get like the weight. the state, like assign some properties here. But we're not doing that now. All we're just going to do is assign appearance. So you right click on this, right click on part 1 on the object browser window, right click on part 1 and click edit appearance. So now we just change the color. I just chose blue because it's easier. It's easy to identify. Okay, then click OK. Click the OK here. And now this part is done. We can rename the part here. Use descriptive name. In this case, I want to rename this. I'll come to this part studio on the bottom, document browser here. Right click, rename, and call this base. So this is the base of what we're making. Okay. This is the base of what we're making. So now this part is done. Let's make the other parts that go together to make the assembly. Right? So the next part will come here again. We'll click on this plus mark here. And on the top, you'll see create part studio.
So I want to say something, Johnson. So yeah. If I wanted to make sure that everybody is done with the first part, or if they're not done, they can just leave the first part and move on so that you don't leave them behind.
Yes, yes. If you're not done with this part, just move on. Open the search vice on shapes. So come here. Come to Unshape, the home page. So click on the Unshape icon. Search Vice Stem Hub. Once you find that, click on it. Then just follow from there. All the parts are already here. I made all the parts before, and everybody can use this part too.
Is everyone done? If you're working on that part, the first part, are you done? So before it moves on to the second one. We want your comment. We want to hear from you. Are you done? Do you want us to wait? We need more comments.
So how do you search for the parts again? Click on Unshape, the top icon. Again, if you're stuck, click on Unshape here, the top icon there. Type in Vice Stem Hub. Okay. All right. So now that we have this, we're back to this part. So click on Create Part Studio.
I'm just wondering why
again we're creating a new part.
If you guys are here, can you respond so we know that you're still here at least? So some people said no result found when they tried to search.
Okay, you couldn't find it at all. Adi, could you search, please? Let me just see. Make sure you. I did the stem hub. There's the capital H between the. So copy that as you see here, please.
No result.
You can't find it?
No.
It should be public. Oh, sorry. I thought it was.
Can I research?
1 second. Just see, make sure everything's fine. Okay. Okay, try again.
No. Still don't get any result.
Yeah, that's the setting says you should be able to.
Yeah.
Okay, I'll copy the link.
Yes.
Let me copy the link and just paste it.
Dr. Adi, I found it when under the public search.
Oh, okay. Thank you. I clicked on the link and I couldn't see it.
Okay.
But I think I only saw one part.
No, if you go to the Power browser, you should be able to see like
Everything. Okay.
everything. Yeah, just down there on the bottom there.
Okay.
Okay. Okay. So does everyone have it now? Okay. Can we go on? Does everyone have this now? Sorry, please, can someone respond?
I clicked on the device, but I didn't have this. It showed me some other like triangle kind of.
Oh, that so
shape.
on the bottom here, you can see you could change it. There are different parts here. See, there's the cantilever,
Okay.
there's the so click on that, you could change it. This is document browser. So there are 4 parts here.
Okay.
So if you click on the bottom here, you could change it.
Oh, okay.
So the first one is the maybe I should put that in. That was the supposed to be the last thing we do. Okay. So the first is the base. Then we could do the jaw and the shadow and spindle. Okay. You can find did you click on the link? If you click on the link, it should direct you there.
Okay, so I found the base.
So does everyone have it now?
Yeah, I'm in the base. Thank you.
Okay. Okay.
Anyone else?
Okay. So okay. All right. So okay.
Anyone else need help with how to change parts, please? Can you show it again, Johnson? Someone is asking how to change the parts.
On the bottom here, on the bottom. Moving my mouse around on the bottom here.
I don't see your mouse.
On the bottom here, you see this. Oh, sorry. On the bottom here, on the bottom. Let me go to the document. Maybe it might be easier to show. So I could. Okay, so right here, I'm just going to zoom into this. So you see right here on the bottom here, this side here, you could change the parts. See the spindle, the base on the bottom here. Okay. Okay, can everyone see now?
Someone asking us that we resend link. Which of the links do you want? Okay, so link to that.
Okay, so is everyone here now? Before I move on, this is probably the hardest one to do. That's why we start with this one first. This is the hardest one to do. The others are a bit easier.
Someone said they can't see your cursor.
I don't think what could I do? I probably have to go to my mouse setting, but I don't think I can make it bigger though. Let's see.
Guys, can we keep going? Yes or no? Have you guys gotten the information on how to change the part?
Okay, is it better now? Change my pointer size. Okay, all right. So now that everyone is here, so on this bottom side, you can click the plus sign here, create new part studio. Sorry. So create part studio. Okay, this opens the same boxes, the same window we had before on the startup. So from here, we want to draw another part. The next part we're drawing is the jaw. So again, from this side, but this time we're clicking on the right plane. See on the right plane here. Once I click on the right plane, I click sketch, then go to the orientation cube right here. I click right. Okay, again, right plane, sketch, orientation cube, right. Once I have that, I want to start again now with a center rectangle. So I click on center point rectangle. From the center, I'll draw out the rectangle. Doesn't matter what the shape is again. Once I have that, press L to use the line tool, or click on the top here. Press L, then draw this shape. Well, just remember, once we're drawing out, you want to see it snap in place. Once it snaps in place, it changes. The color changes from light blue to like light blue with orange dashes. So now I have this. Next one, drag out. Next one, too long. So line tool again. I press Ctrl Z to undo, and I press L again to select the line tool.
Sorry to interrupt, Johnson. My rectangle and other 2D features are not coming up. Any L?
Because I probably didn't click sketch. That's probably what happened. Let me just go back again. I'll start from scratch. Okay, so this is what when we start the screen, this is what we see. So click on the right plane. Click on the right plane here. Then click sketch. Make sure you're clicking sketch here. Once you click sketch, click right here again on this side. On the orientation cube here. Click right. Then click on the center rectangle tool. So did you have it now? Distinct console, do you have it now? Do you have it now? Oh, okay, so if you don't have the Ctrl Z, if you don't have the center rectangle tool, you could drop down, click the drop down menu. You could just press R key. R key on your keyboard engages the center rectangle tool. Press R on your keyboard. Okay. So press R on your keyboard to get center rectangle tool. Then press L to get the line tool. Then I'm just drawing a line. Make sure it snaps in place. If it snaps in place, you can see it snaps in place. Drag down. Snaps in place again. Snaps in place. So now we've drawn this. It closed the sketch because we came to a center point again. Remember to click show constraint so you can see all the stuff that is there. So I want this to be vertical. This is parallel to this line, which is good. This is vertical, which is also good. This is horizontal. This is vertical line here, which is fine. This is parallel to this. Since this is vertical, it's fine. Okay, now that I have this shape drawn out, you could also delete. Sometimes some relations might show up that you don't want. So let me press escape key to get back to the pointer selection tool. I could delete anything I don't want by just clicking on it and hitting delete on the keyboard. Okay, so line tool again, press L. Then from here, I drag out. Again, we're just drawing out the rough shape. Once it snaps to place, drag out. Okay, so see my line here didn't snap to place. So L again. So wait for it to. Okay, so you see this line here? This line here doesn't have a, so I'm going to press escape key to get a selection tool. This line here doesn't have the vertical sign, which I wanted it to. See, this one has it, this one has it, this one has the horizontal sign. This one has it, but this one doesn't. So I can click on this line here and go to the relation here, set which relation I want. I want it to be horizontal. So I click on horizontal or press H. So you see now, it's there, which is what I wanted. You want to ensure that it has these relations, vertical, horizontal. So after drawing out this basic shape, the next thing now to do again is to use the dimension tool, which is here, or press D on the keyboard to set out the dimensions for this. So first, let's say I want to set this one out. Let's say I set this to 1. I set this top part to 6. Again, I can zoom out, position it however I want. Zoom out. So this, I set this to, I'm still have the dimension tool selected. You can see the cross mark is there. The dimension tool is still selected. So select this, set it to 5. If this is wonky, you could just move stuff around. Move it around, move the blue points around. So now click on this, set it to 1.5. Set it to 1.5. Set it to 1.5. Sorry, just set this to 1.5. Then I can set this line. Set this to 1.5. Then I can set this line here. This point here. I click on this. See, I first click. Let me do it slowly again. I click on this line here. Change it to orange. Click on this one. And set this to 2. Okay. Then on the top here, click on this top part here. I want to set this to 8. Okay. See, the shape is not exactly how I want it to be, which is fine now. But we can see, but you can see the center rectangle we drew on the bottom is fully defined. The only thing that is not defined now is this blue line and this blue line. They have a size, but they do not have a dimension. This blue line has a size, but we don't have a dimension for them. So still with the dimension tool selected, I'll click on the origin point here, then click on this. Click on this line here. You see when I did this, it tried to first do like a diagonal line, but just move it to what you want. Move it to like a horizontal position. Then I'll change this to 2.5. Okay. Same again. I'll select this point here now. And select this line. Select this line. I can select this or this, whichever. I'll just select this one here. So now I'll change this to 4. Now the line is fully defined. Now the object is fully defined. I can remove show constraints just to see like how each of my dimensions are positioned, just to have a clearer view. Okay, so is everyone following? Is everyone up to this point? Okay, so where you stuck? Where you stuck in? So is everyone following? Please, could you respond? Okay. Okay, is everyone there? Is anyone still behind? Can you tell me so I could help you or know where you're at? So one person is done. Andres is done. Good job. Okay, 2 people are done so far. Okay, so I'll continue then. I'm assuming everyone is done.
Derek, how can we help you? Okay, thank you. Derek, somebody's trying to help you. Johnson is trying to help you. Do you want to let him know where you are?
Okay, you could just slowly add dimensions. You can also follow the document to see what dimensions were added. If you're stuck on how to, which points to click. Okay. All right, then, so let's continue to, so click again. Now that we're done this, we click again to extrude boss base. So we set this now. In this case, we just set this to 3 inches, right? So once we've done this, the next part now we're just drawing. We're just going to draw a hole here. We're going to draw a hole here. So a hole in the center. So click this face now. So okay, first click. Once you do that, we select that. Click on this face. Make sure you select the check mark. Click on this face. The face gets highlighted to orange. Okay, so I'll just do this again. So once we've gotten this on the top here, we click on this, the extrude boss base, extrude boss, or Shift E. You can just press Shift E on the keyboard. Then change this to 3. After changing this to 3, just press OK. So now that we have this, we click on this face. Then click Sketch. Click Sketch. Again, show constraints. So just press the C key on the keyboard. Press C. Press C and just draw a circle. Doesn't matter where the circle is. We're going to put dimensions of the circle. Then press the D on the keyboard again. Okay. Okay, so I mistakenly pressed it twice. Press the D on the keyboard. Then if I press the D, I could drag the circle out. I could drag it out now. You see, there was an arrow that showed on the top. Then just click this and change this to 2 first. Then click on this edge here and change this to 1. Click on the circle again and click on this edge here and change this to 3. So it's done now. So I'm just moving the arrows out so you can see. Oh no, I click on the wrong shape. So I can delete this. I click on the wrong side. So I'll change this to 3. See, I clicked on the wrong side, so you started from there instead of clicking from this side to this side. So now it's in the center. This is how I want it. Okay, then after this again, we'll click on the extrude boss base, which is right here. Click on this. But this time now we'll click remove. and change it from here. We click remove here on the top here, remove here, then change it from blind to true all. Okay, or we could just set the depth. Since we know how big this, we could just set it to 3, but true all is just easier in case we change the size again. It means it to update with it. Okay, so now that we have this, we could use the right mouse button. I'm using the right mouse button to just move around to see what we've done so far. I could click on this, click on this dot here to get this isometric view. Once I have this view, I'm fine with this now. I can click OK. I'm done with the extrude. I want to click on this fillet icon here, this one here, fillet, or Shift F. So I'll press Shift F. That shows up. Now I need to choose where I want to fillet, what side I want to make round. So I click on that edge first. I click on this edge. Then I change this to 4. You see, now that automatically just rounds out the feature because the size of this shape was 8. And if I make one side, I have a radius of 4, the other side a radius of 4. It makes it round like a semicircle. Okay, then I click OK once this is done. Then I click here and change the appearance. So I want to change the appearance to whatever. Let's say I choose this time I want to make it green. That's fine for me. I don't really like the green. Okay, this is good. Okay, so now I'm done with this part. Now we're going to make another part again. So here we can rename it to right click it, rename, and change this to jaw. So right click, rename on the top here, change it to jaw. So again, add another part. So now, so each of them, I've made them on different plane. The first part we made on the front plane, the second part we made on the right plane. This part again, we're making on the right plane. The reason I'm making it in this specific plane is that when we're placing it in the assembly, it'll be easier to move around. If they're in the right plane, and once you're starting, it'll be easier in the assembly. So that's why we're picking this specific plane. If not, you could draw from whichever side you wanted. You could draw from which, it doesn't really matter. But once you get to the assembly, it becomes easier. So that's why we choose the right plane here again. Right plane, go over to sketch, change the rotation cube, come to the rotation cube here, and click right. Now we're drawing out the shaft. This is an easy part. So here we just click C to get the circle tool.
Do you want to make sure that it's coloring, please?
Okay. So is everyone here? Is everyone with me?
Are you all with him? Okay. They are. Great.
Okay. Okay, please, if you're not following me, just tell me so I could maybe slow down or redo something again. Okay. So press C. So remember we click on the
slow down a bit.
Okay. Okay, so I'll just redo this again. So we come in, this is what we see when we start. We see this. So we click on the right plane here, the right plane, this part here. Then we go to sketch. Sketch is on this part here. Click on sketch. After we click on sketch, we click on right again. So this makes it normal to us. Now that we're here, click on show constraints, which we want to do. Press C. Press C. Press C. Then once we come to the center here, the origin point, we click and we drag out. So now we see there's this condition. It means it has a position. Now all it just needs now is just one dimension. It has a position. It needs a size. So press D key. Press the D key. Then I'll press the D key or click dimension up here. Click on the circle. Drag it out. Click on the circle and move this out. And enter 2 here. Okay, we're entering the dimension to 2. So now it's black, it's fully defined. We only need one dimension for this. Then we'll come to the top side here again, the extrude on the top side here. Shift E, or press Shift E. And set this now to 28. Set this to 28. I can use the right mouse button to move around to just see what I did. Okay, this looks good. Accept. Again, click on the right plane. Click on the right on the rotation cube. right on the rotation cube. Once I have this, click on this face, click sketch again. Now we'll press C again. We'll join another circle. From here, we just drag it out. It doesn't matter what the size is. We'll set the dimension. It has a position. Remember to show constraint. It has a position. But now it just needs a size. So press D again, the D or click dimension 2 here. Click this and change this to 1. So now this is fine. Again, we'll go to the extrude over here or press Shift E and change this to, this time we're going to do a depth. We're going to be removing. Remember to click here, change remove. We're removing the material. You click remove and change this to 3. See, it took out some material from there. Then click this, accept. So we're done with this part now. We just change the appearance. You could change the appearance if you want to. So edit the appearance. I'm just going to pick whatever color I think looks good. Okay, this looks fine to me. Okay, so we have this now. So we're done with this part. So come here, right click, rename this part to shaft. Okay, we have the shaft done now. So we have to make, there's one more part left to make, and that's the spindle. So again, we're creating a new part. So come to this plus sign here, click on this plus sign, create part studio, go up to create part studio. Okay, so someone is locked. So where are you stuck? Where are you? Did you? I cannot. Sorry, I didn't see. Where are you now? I can undo where you stuck at. Did you get the circle? Okay, so we started here. Edit sketch. We started so did you get the? Okay, okay, so from the start. Okay, I'll start again. This is. So I'll delete this. So press C on the keyboard. Press C on the keyboard. Once you have that, see the dot here, this dot in the center. Click the dot in the center and drag out to any shape. Drag out to any shape, okay? Now that we have this, we have the circle done. Now press D on the keyboard. Once you press D on the keyboard, click on the edge, click on the circle, click on the edge of the circle. Click on the edge of the circle and just place this wherever. So you click once, then place this wherever you want. Then change the number, press 2. See the number changes here and press enter. Now we've made the first circle. So after making the first circle, come to the top here and click this or press Shift E on the keyboard. So here, click this, extrude. So once you click this menu pops up. On this menu, we're adding, but we're going to set it to, we set this to 28. We set this to 28, we press enter. You can use the right mouse button to move around to see what you just made. Use the rotation cube to put it back normal to you. So 28, set this to 28, then click OK. Make sure you're on the right, you're on the rotation cube. Look at my mouse, the rotation cube, click the right button, click the right here. Once you click the right, click on this face. Click sketch. Now on this face again, click show constraint. Click show constraint, then press C on the keyboard. Press C on the keyboard. Press C on the keyboard and start drawing from the center dot that appears there, the origin point. Drag out. Now we have the shape. Press D on the keyboard again. D on the keyboard now. This changes it to the dimension 2. Then click on the edge of the circle. Click out. Then just set this to 1. Set this to 1. Yeah, someone just asked, could you draw both circles? Yes, you could draw both circles at once. But once you're selecting the extrude feature, you have to specify, okay, which part of the circle do I want to extrude? Do I want to extrude one or extrude two? You could draw both circles at once. Yes, you could do that. Even for most of the stuff we've done, some of them you could do it in one step instead of doing it in 2 steps or multiple steps. Yes, you could do it. So after clicking the circle, setting this dimension, I'll click again to extrude, or Shift E, click on extrude. But now make sure, but this time I don't want to add material, I want to remove. So remove, and set this here, change the depth value here to 3. You see that's taking out material, set that to 3. Then click OK. So this part is done now. So is everyone here? Did I go too fast again? Is everyone here? Please tell me if you're following along. Okay, so now you can change the appearance. So appearance, just come to the part down here, right click. See edit appearance right here. Edit appearance. Then choose a color. I just want to choose this one. This one, I think this one is good. Accept. And that's it. We're done with this part now. Okay, so now we'll create the last part now. We'll come here again. Insert new element. We're inserting a new, click on the plus arrow here. Then on the top again, we'll create Part Studio. So create Part Studio. Again, the right plane. We're going to be doing it from the right plane. So click on the right plane. Click right. Or you could actually this one will be better from the left if you can, but maybe click the left this time. If you want to, you could just click the right again. Also click the right plane. Let me go back. Click the right plane. Click sketch. Then turn around and click left. Okay. So if you see now, the right is like spelled reverse. It means that we're facing, we're the back of the right plane, not in front of the right plane. Okay. So now again, using the circle tool, just click on circle here or press C on your keyboard. Probably the easiest thing to do is just use the shortcut. Press C on the keyboard, click the center point, drag out. Now press D again on your keyboard to get the dimension tool, or click D here. So press D, click this, click out, and enter the value 3. Okay, enter the value 3. So now that we have this, again, we'll go to the extrude again. I'll press Shift E on the keyboard. Extrude. Extrude. Now we extrude this by 3 inches. We'll press 3 here. Just press 3. Press 3 here. We click the extrude after drawing the sketch between dimension. We click extrude, press 3. And click OK. So now that we're still here, remember we're on the left side. Click on the left again. So we want the left, want to be facing this way. Then again, click on this face. Click on this face, face changes to orange. Click on sketch. Then press C again. We're using a circle tool. So press C to get the circle tool, or press circle here. C to get the circle tool. Click the circle, click here. Click on any position, it doesn't matter. We use the dimension to set it. Press D to get the dimension tool. Click here, click on the circle. Now set this to 1. Press enter. Then click extrude boss or base. Okay. Here, click extrude boss or base. So here we're going to we're adding material. We're adding material in this case. So in this case now we change the value here to 2. See, change it to 2. This is what it should look like now. I use the right mouse button to just rotate. So we'll go back again, click left. Once I select 2. So is everyone following up to this point? Please, if you're following, can you just quickly respond so I know everyone is. Okay. Okay. All right. Okay. The last, okay, go over. So the one we just made. Okay, I'll undo that.
According to Wikipedia, carbonated water is water containing dissolved carbon dioxide gas, either artificially injected under pressure or occurring due to.
So remember to go to, once we have this, go to the left, click the left plane. Click the left plane, click the left here on the rotation cube. Press C on the keyboard. Click on the center dot here. Drag out and just create this. Doesn't matter what the size is. We have a dimension now. You can show constraints. So we want to see this there mean that we're on the center point. We're coincident with the center, which is what we want. Then press D on the keyboard. That changes it to the dimension tool. See, I press D, changes the dimension tool. Then click on this and just put it anywhere and change this to 1. Now that we've drawn this out, on the top here, press Shift E or press Extrude over here. Shift E or press Extrude. Click this. Okay, then set this now to 2. Okay, now that we have this drawn, click OK. Once click OK to accept the shape. So is everyone here? I'm assuming everyone is here. Who was the person that wasn't here? Okay, Sylvia, are you done now? Did you follow?
I'm following, thank you.
Okay. Okay. Okay, so now that we have this, we've drawn this part, then the next thing to do, we want to put the handles. We want to create the handles on this. So rotate this, use the right stick to just rotate this. Just try and get it to something like this, or use this here, use the rotation cube. Go to the front, something like this. Then now we click on the front. So you click on the front. What did I do? Click on the front. Again, click on sketch. Now we're sketching on the front plane. And you see the front plane kind of divides this into 2, which is what we want. So then I click on the front on the orientation cube here. Press circle on the keyboard. Press C on the keyboard to get the circle tool. Now click on this line. You see this automatically shows up the vertical bar. The horizontal bar shows up. So now we click on this, drag out. Now we have to set the size and the position for this. So press D again on the keyboard to set the dimension. Change this to 0.5. So 0.5. Now that we have this, click on this again. Click on one of the edges. If you click on this side, click on this side. If you click on the other side, click on this side. So I click on this side here. So I'll click on this side here. Then I'll set this to 1.25. So now the circle has changed to black. So I'm done. I've fully defined the circle. So again, click on extrude here. Extrude shape. This time, the option here, instead of leaving it a blind, we'll come here, we'll do symmetric. Because this front plane is in the center. So we'll do symmetric. Right? And we'll make this, and we'll extend this out to 8. Sorry, maybe even 12 instead of 12 or 13. Oh, I think 15 is better. Yeah, 15 looks, okay, 15 looks better. Okay, so now you should have something like this. After setting it to 15. So is everyone here? So change this part here to symmetric. It was blind before, switch it to symmetric. Then enter 15 here. Then press OK. So this part is done now. We could change the appearance here. So edit appearance. Change this to whatever color you want. I'm just going to do maybe light dark purple. That looks good to me. Okay, so is everyone here now? Okay, we'll let this here. Okay, since everyone is here, okay. Then the next part is just to click on the assembly one here. You see on the bottom here. But first, okay, let's first rename this. Let's rename this. Right click on this. Right click, rename. It's not important to rename, but it's good to rename. It's a good habit to give your part descriptive names. Okay, so let's call this the spindle. Okay. So now, after renaming this, click on assembly one. On the document browser, see where my mouse is? Click on assembly one here. Okay. Now we're going to make the assembly. So here we click insert. So once we click insert, you see the drop down list. After we click insert, the drop down list shows us like all the parts we've just made. All the parts we made are in this document. Right? So first click the base. Once you click the base, just come out and click outside. That places the base. If I click on the jaw, I just come out. I'm zooming in or out. I'm using the scroll button to zoom in or out. I'm just placing this wherever. It doesn't matter where you place it now. So click on the shaft. Then just click where I want it to be placed. It doesn't matter where I place it. I'm just placing it anyway. Click on the spindle. Again, doesn't matter where I place this. I'm placing it anywhere. So I'll place it here. Okay. So we have all the parts in now. So this 3D space now, this 3D space, all the parts are, so when I'm done, I'll just click OK here. I've accepted. I'm done putting all the parts I need for this assembly. In this 3D space now, you see everything here can still move. Everything can just move around. You can move it wherever you want. Okay? But if you're doing an assembly, you need to have one part that is fixed. You need to have a part that is grounded, right? So if other parts want to join to it, you need something that can stay one spot so other things can come and join to it. If that makes sense. So right click on this base here, this is the base we're going to be using. Right click on it. And down here, you should see like, so you should see the option fix. Okay, see now the part is fixed. And right here, you can see there's an icon here. This icon changes and that means that we fixed this part. Now this can't move anymore. See when I try to drag it, that icon pops up, means it's fixed. This, however, can still float, which is what we want. So taking this, click on this. So now we have all those parts together, but for us to put all this thing together so they can move how we want it to move, we need to set mate relationships. So what is the relationship between this and this? What kind of relationship should they have? How would they interact with each other in this assembly? So we click on this. Let's click on the shaft. Clicking on the shaft. The shaft here. The shaft has to go here. We know the shaft has to move in between the slot here. This has to be here. This has to be in front in the spindle. So the relationship we choose first. Let's choose the. So and Onshape has like a different type of way of like mating parts. It's not very common. This method of mating is not common. They use like what do you call this? A more like a advanced mate instead of just doing relationships. So before, like other CAD software, you could have relationship like coincidence, meaning that these two faces should be like on the same plane. But Onshape, they have like a different method. So the method they have is like they add this more advanced mate that you could just use one step to do multiple things at the same time. So the first mate we're going to be adding now will be the cylindrical mate. Cylindrical mate. The cylindrical mate is like this icon here that has like this roll around and an arrow on the top. So if I click the cylindrical mate, so now see here, I need to set the mate connectors. Okay, so somebody says start assembly again. Okay, so let me just quickly. Okay, so click on insert here. Insert on the top here. Click on base, click on the base, then just click anywhere here. Just place it anywhere. Go back again, click on jaw, place it anywhere. It doesn't really matter where we place it. Click on shaft. Doesn't matter where we place the shaft. Again, we just click on shaft and we place it anywhere. Click on spindle. Again, just place it wherever. Okay. So right click on this base. So here we're going to fix this. So first, I'm done with the certain parts. So I'll right click on this, fix. Because everything is floating now. We need one of them to be at the specific position. You see here, this dot here in the center, that is the origin of this entire document. That's where everything starts from. That's the origin point. So now that I have this here, then I could add this. I want to create a mate relationship between this. So I'll use the cylindrical mate. The cylindrical mate is up here. So click on the cylindrical mate. Can everyone see where the cylindrical mate is? If you hover around it, it should say cylindrical mate. Then now it tells me to select mate connectors. So I want to select this face here. You see this face without the hole. You see this other side has the hole. I don't want that side. I want this side, this bare face here. I'll click on this face. Hold on, I didn't click on the face. Okay. So click on the face. Then here I'll click on this face too. Click on this face here, you see? I'm clicking on this inside of the circle here. Inside of the circle here. So see this what I see? And if once this is fine, you could also click the play button here to see if that's what you want to do. Yes, that's what I want to do. This should be like a bolt that spins. And if I play the animation, it shows, okay, this is what I want you to do. I want you to be a cylinder. I want you to be able to rotate, and I want you to go in and out. So that's good. Once I'm satisfied with this, I could just click the check mark here. So play to just see the animation. That's what I want you to do. And check mark here, done. So now that I have this part, then I need to add a mate between this and this and this, right? So here I want a fasten mate. I want this piece and this piece to always be together. They should always be together. They shouldn't be like free to move. If this is moving, this should be moving as well. So that's why I need a fasten mate. So on the top here, there's a fasten mate. So I want to click this here. Fasten mate. So I want to choose this face. I'm choosing this face here. You see the face here? Not this face here. See this face here. Once I choose that face, I choose this face as well. This is fine. Fasten mate, there's no animation fasten mate because those two parts are together. They can't move relative to each other. So once I'm done, once I'm done with this, I'll click the check mark here. So done. Now the next part will be this, adding this to this. So I want this here to be in between this and slide front and back. So to do that, I need the slider mate. So I want this to be able to go from back and forth within this groove here. So I'll click on this. I'll click on the slider mate. Slider mate is up here. If you hover around, you can see the slider mate. Click on the slider mate. Now click on this edge. I click on this edge. I didn't click on the edge. Okay, click on the edge. So now it moved. So once click on the edge, the tool is moved into place. Then if I press play, that's exactly what I want you to do. Okay, that's good. Then press OK. So now just one more mate that is left. So again, I want to connect this to this because this should move this back and forth. So I'll click again. The mate I'm going to use now is the revolute mate. So here the revolute is just beside the fasten mate. If you come here, you see the revolute mate. Click on the revolute mate. Click on this face. And click on this face here. I'll click on this face here, inside here. Okay, the revolute mate. This will allow it to rotate, but it's rotating the wrong one. Okay, this is fine. I click OK. Okay, undo, something is wrong. I didn't click the right spot. I didn't click the right spot. So I just undid that. I just used Control Z to undo that. Revolute Mate. See. Okay, the mates didn't work. Put this out. I think I'll just put a fasten mate since the Revolute didn't work. A fasten these two faces. Can you solve? Okay. Okay, it's better now. Okay, so that's roughly the assembly. We're done the assembly. So I used the fasten mate in the end. So did everyone follow up to that point? Let me just undo this, undo this. I don't know why so this also went in about assembly. Sometimes some parts the mate assembly might not be able to, the solver might not be able to solve the mates correctly, how you want it to be. So but in this case, I just use a fasten mate. I'll fasten this face and this face. So again, let me just move this out. So fasten mate up here, click fasten mate, click on this face, and click on this face. Click OK here. And we're done the assembly. So is everyone done up to this point? Okay, yes, Willard is done. So just a quick question, Willard, have you done CAD before, or is this your first time? Okay, since majority of people are done. Oh, okay. Okay, so is everyone done? Please, if you're stuck, just tell me where you're stuck at. I can just go over quickly. We still have to do one more part. Then I'll show you like there's a simulation. There's still one more part to go after this. Just want to make sure we're still this. If you're done this part, there's still something else we still have to do. Okay, all right. So I think everyone is done.
Guys, we still have the 3D printing session. You guys are still just doing the design.
We're not done. We're not done. We're just done this part. We're done this part. There's still one more thing we have to do before we're done today. There's still one more thing I have to show. So everyone is done now. So remember the Vice stem hub? There was this part that everyone saw. The first part you saw, the triangular shape. So let me just quickly go over. So you see this? So now we've made this part, but the next part and after design phase is to manufacture this. This stuff we just designed now is unmanufacturable. There's no way for someone to put this part. There's no way for someone to put some of these parts together. Right. So first of all, this should be like hello? Sorry, somebody on. Okay, so there's some of this parts that you cannot easily make them. So first of all, how are we going to get this part here into this? We could turn it sideways and put it in. This is possible, but for some of the parts, it's hard to connect. So when you're designing, most times when you start with your first design, it might not be your final design. So design is iterative process. So for example, now maybe this doesn't even meet the weight requirement after we set the after we set the material, it might be too heavy for what we intended it for, or it might not just have enough strength to undergo what we intended it for. So another way we can also verify what we did without actually manufacturing it is to do a simulation. So again, we'll be doing a simple simulation. So everyone has this. Everyone has the vice stem hub, right? I don't want anyone. We can make this part again, but it'd be easier if it would just be easier if everyone could just put this part to their own library. So everybody able to download the vice stem hub? I think most people were able to get into the vice stem hub, right? So I'm assuming everyone was able to get to the vice stem hub. So if you were able to, so now we have to go to SimScale. So the next part is to do a simulation study. So simscale.com, we have to sign up to SimScale. So just enter simscale.com. Okay, I'm already logged in. So Adi, have you used SimScale before?
No.
Okay, so could you do like the sign up? Could you share your screen and help with the sign up? Help with the sign up of SimScale. It's pretty straightforward. Again, it's the same idea, and it's connected to you could connect Onshape to SimScale. So Adi, could you share your screen and like do the sign up so everyone can see? I can sign up again, but I don't need to have like 2 accounts.
Okay, just hold on. You are currently presenting.
Okay, sorry, I have to stop presenting. Okay. Okay.
I don't know what I've done. It said I can't share my screen. Hold on. It said I can't share my screen. Let me see.
Okay, I'll open. Let me see. Maybe I'll just. All right, I'll try and just walk through I'll share my screen again, and just walk through. Okay, I'll share my screen again. Okay. Okay, so SimScale on the top here, if you go to simscale.com, let me just type that in here. Okay, SimScale.com. On the top here, you see the login. Log in and sign up. Click on sign up. Okay, here you put like where you're from, email, and all that information. Then you create a free account. It's as straightforward as Onshape 2. Or you could just sign up with Google. It's usually easier to sign up with with a Google account since you wouldn't have to put in any information. All right, so if you've done register for SimScale, please could you just notify by writing down in the comments. Okay, one person is done.
Johnson, how are we doing with time?
Huh?
How are we
I
doing?
think we're still good. We're still good with time. We're still good with time. We're still on schedule.
All right,
We're on
thank you.
schedule. I just if everyone is when everyone is so yeah, Willard, you asked the question is okay, Andrew is done. So Onshape. No, most people don't use Onshape to design. It's not very common. It's still like a very new product. It's kind of like still in the startup phase. Most they're more like advanced and developed CAD tools. The most common one is SolidWorks.
Yeah,
SolidWorks is the most common one.
SolidWorks is peculiar to Canada. The US is more Creole.
Yeah.
Creole.
But the price of it too is like because Onshape is free, many people can just use it and hobbies can just use it. SolidWorks is not cheap. Like in Canada, a seat is like a personal seat is like 5,000 to buy for one user, $5,000. So it's not cheap. So you could get it if you're a student, you could get like a free version as a student, but to get like a full version. So that's why most times you don't need to show people like the intro to CAD, except it's like you can get student version. Okay, so I'm assuming everyone is done. If you're not done, could you just state you're not done so before we go to the next stage? Okay, so I think I'm assuming everyone is done now. Okay, then let's carry on. Okay, so come here. If you're here, maybe you might not be here, but if you're here, you could just click on the icon with your name and click on dashboard. Okay, on the dashboard, can everyone see my screen? Oh, my screen is not sharing. 1 second. I thought I was sharing my screen. Sorry. Okay, let me share this. Okay, so if you're here, if you're on the screen, on the top right corner here, you could click on dashboard. Just click on dashboard here. Then here, you could specify, okay, what do you want to do? What do you want to do? So you click on new project. So what project? So actually, let me explain this first. Let me go back and explain this first. So technically, this is like, so what we're making here is a shelf bracket. So think of, okay, we're designing a shelf. We're designing a shelf that we want to hang on the wall, but we want to see like, okay, what kind of brackets can we put under the shelf? So think of this as the bracket, then the shelf is just lying on top of this. What kind of bracket can we put under the shelf to support the shelf's weight, right? This here looks okay. It probably could support the weight, but how can we be sure that this is a good design? So that's what we're trying to do now. We're trying to simulate if this is a good design. Okay. So come here, let's call our project shelf. Just call it whatever you want. In this case, we'll try and use descriptive name. Bracket. So you have to choose a category. So if people are searching for, searching for like this shelf bracket, they can find it. What category is it under? They're trying to search and use filters. So let me just put learning and teaching. It doesn't really matter what we're using for. I'm not adding a tag. If I want to add tags so people can find it, but that doesn't really matter to me. So I could just create project. So once I create project, you should notice now, you see right once I create project, this window is open. I could add stuff to this, I can import stuff. But right here on the here on the right side, you can see import from Onshape. I don't have to do anything. It already knows that Onshape is already integrated into this software. So I just click import from Onshape. Again, this is a free tool. So some of the features you have will not be complete. You won't have like you won't have full advantage if you actually paid for it. So again, so I'll click on the Vice stem hub, which is what I wanted. But which part do I want? I want this cantilever. I'll click on it. So I'll click on part 1. So Vice stem hub, click on cantilever, click on part 1, and click import. So it's processing now, is importing. Okay, it's almost done. Okay, it's done importing now. So once it's done importing, you can see, okay, let me just make sure I close. Once it's done importing, up here, you can see under geometries. So under geometries, you can see here, again, look at your rotation cube, the same thing we just saw now in the CAD file. The rotation cube is on the right, so where we are, we're looking at it from the top. So this is where the shelf will rest on. So I can use this time I use left mouse click to rotate around to see see the bracket. Oh, I stopped sharing. No, okay, no, but I can still see, I'm still sharing. I'm assuming everyone can see my screen. It's still sharing. So can everyone see my screen? Someone said I stopped sharing.
Yes, I can see your screen.
Okay, thank you. So again, you can rotate the part and just see what we just put in. Okay, so now we've put the geometry we want to analyze in. So under simulations, click simulations here, click the plus arrow. So what kind of simulation do we want to do? So it tells us, okay, well, we're trying to do like a flow study, but for our case, we're doing like a simple static study. We're trying to see if we put some load, if we put weight on the shelf with this bracket, will it break? Will it fail? Essentially. So here I'll click static. Once I click static, I'll just create simulation. So static, create simulation. Okay, so somebody said you didn't see how I imported. So if you just click, should I start again? So Ngozi, were you able to? Okay, we're good. Okay, so once you click is imported, just create simulation. Choose static here. Make sure you choose static. So which one do you want to do? You want to do a static study? Create simulation. Okay, now we have an object in. So now the only thing we have to do now is just literally go down this list and fill out all the parts that are important to us. So we have our geometry, that's good. So contacts, this is like if we have like multiple parts in this. Let's say I had the block of the shelf on top of this, and I was applying weight on the block itself, then I'll have contact. But there's only one part here, so there's no need for contact. That's fine. My model is there. So here, materials, I need to specify what type of material it is. What type of material do I want? So here, I'll just click on the plus sign. It shows me what kind of material. So let's say I was choosing, I just choose aluminum as like so here I choose aluminum. You see, it shows me the Young modulus, the Poisson's ratio, and the density. So the Young modulus just tells me like up to what certain point, up to what certain stress, or up to what certain stress, more simply, like what certain force could I put it to before this stuff becomes plastically deformed. So what that means is that, so think of like a rubber band. If you stretch out a rubber band, it comes back together. But if you stretch it out really, really wide, it will lose its shape. So that's plastic deformation. So up to this certain pressure, the material will still be able to come back to its original shape. So that's what this is. So the higher this is, the more the material can withstand. And some material have like lower Poisson ratio. It means like how they shrink with how each side compresses, how the latch. Forget about Poisson's ratio. Let's just focus on the Young's modulus. Okay. So we chose aluminum. You could choose like whatever material you want. You could also apply custom material. Okay, let's say you did a test and you have some material. You want to apply custom material properties here. You can apply them here. So I'll choose aluminum. Apply. Okay, this is good. Select OK. I'm gonna select aluminum. It's select aluminum on the body here. So then this is the boundary conditions. So boundary conditions means that, okay, what kind of how is this part connected to other things? So for example, so here I'm going to I click on the plus sign. I'll click fixed support. So what that means is like, okay, if I was going to put this shelf, I'm going to use this holes here to mount it to the wall. So it means that those places will be fixed. Those places will not move. If it's mounted to the wall, those places will be fixed. So I'll click on this hole and this hole. You see the two faces have been selected. Fixed support, I click OK. That's good. Then again, I'll click on the plus sign. I want to apply a force to this. So I want to see at what point would this break, right? So I'm going to apply a force to this. Most specifically, it's better to apply pressure, but let's just go with force. So let's assume that, okay, pay attention here to the rotation cube here. You see there's the Z, there's the X, and there's the Y. And you see here there's the force direction on the X axis, Y axis, Z axis. So force is a vector quantity, so it means it has direction and it has magnitude and direction. So I want to apply, if this was a shelf, the force will be applied on this part here. So it means that the weight of the shelf will be on this part. Let's say somebody was sitting on the shelf. Let's say a human being was sitting on the shelf, and that human being was like 110 kgs. Approximately, that force is like 1100. The person was 110 kg, so that the force is approximately 1,110 newtons. So just multiply by 10, roughly. Okay, so apply that force here, or I can apply more. So there's also something you also consider. If you're designing something, you put like what is called a factor of safety. How much should this withstand before it breaks? Maybe even withstand twice than what you expected. But for this case, let's just put 1100 minus 1100. Okay, so somebody says start the process again. Where did you, Tosin, where were you stuck? Okay, I can start again. So were you able to import the geometry? Were you able to start by putting the cantilever in? Hello, Tosin, were you able to do it? Okay, import. So mm. So is anyone up to this point? Sorry, maybe I will go back again from scratch. Is anyone up to this point? Let me just know who is behind. Almost. So please, if you're at this point, please could you just signify if you're here? Could you just say I'm already at the spot? Okay. Okay, my screen didn't show how important the file. Okay. All right, I'll just start again. So again, from this screen, I'm going to start again slowly. On the top part, click New Project. Choose a name. I'll call it shelf bracket again. Shelf bracket maybe 2. Shelf bracket 2. Put some description. You need to put a description. Shelf. Choose the category. It doesn't really matter in this case. Like I said, I just put learning and teaching. You don't have to add a tag. So shelf bracket 2, just put any name you want. Shelf, but it's good to have descriptive name. Then learning and teaching, then create project. Okay, once I click create project, you see this window pops up. On the window, you see like this import from Onshape. Import from Onshape. I want to click import from Onshape. So once I click import from Onshape, this window appears. In this window, I want to click Vice Stem Hub, the one I shared earlier, Vice Stem Hub. Click on Vice Stem Hub. Then it brings the list of all the material, all the objects we created there. So I click on cantilever here. Okay, click on cantilever, then I click on part 1. Then I just click import and just wait for it. Once it's done importing, this will go away. Okay. Oh, I'm sorry. You guys can't see the import. You can't see the import. My bad. I need to change my sharing options. That's why you didn't see my sharing options. Sorry. To change my sharing options. Sorry, when I was sharing the screen, I didn't share window. Okay. Okay, so go back, go to dashboard. So dashboard, new project. I'll just put something quickly here now. Let me see. Oh, you can't see my screen. Second. The heck is... Okay. Sorry. Okay. Okay, now it shows showing. I just want to make sure. Sorry. Okay, so new project up here. Again, just put whatever you have. Shelf. Just put whatever name here. Choose a category. Learning and teaching. Shelf. Just put whatever you want here, then create project. Okay, so yeah. So now look at this import from Onshape. Import from Onshape. Okay, so I'll click import from Onshape. Why is it not sharing the screen? I need to share this other screen. It's not showing the screen. I need to change it. The pop-up screen is not coming up. I need to just change that. I don't know why it's not working.
Uchi, can you help? Uchi, are you there?
Yeah, I'm here.
Can you help?
I don't know. This one of the screen just is not showing up. Been trying to show the screen. Okay, so yeah, I just
I'm not sure what's going on.
So okay, so I'm trying to share a particular screen. So here, when I try to So when I click, see this comes up, import from Onshape. Once I click this, I have another pop-up screen, but that pop-up screen is not coming up. It's not showing up. I don't know why that. And I'm doing share this window, but it's not showing that screen. I'm trying to see maybe. Okay, I'll stop presenting and present only that screen.
Yeah, maybe that one. That one.
Shoot, still not that.
Are you presenting your entire window?
Screen. Yeah, I think I was doing the entire. I was doing the wrong one. I need to do my entire screen. Okay. Okay. So once you click on it shows. Once you click on the Onshape, this should come up. Import. So I want to click Vice Stem Hub. Vice Stem Hub. Cantilever. To make sure Vice Stem Hub, then click Part 1. Okay, someone said I can import the. So the Vice Stem Hub is probably not saved to your directory. You need to save it. Let me go back to Onshape. So once you search it, you need to create a copy of this on your own. You need to create a copy of this. That's why it's not appearing. Once you search Vice Demo, make sure you have a copy of it. Or you know what I could do? You could import from your computer too. Let me see. I'm going to share the OneDrive, so maybe you can download it and import to your computer.
Johnson is already too.
Yes. Yeah, we're almost done. We're almost done.
Okay.
We're almost done. And I could just show everyone the other steps, and maybe you can import the geometry later. I'll just show the other steps. I'll show the other steps. Okay, I'll show the other steps. Okay, since no one could get the import, I'll just show the other step. I'll show the other step. I'll show you how to. You can just import it directly. Drag and drop the file there. I'll just show. Maybe I'll just show the final. Actually, I'll show the final here. Show one I've already done before. Okay. So again, this one I already did this. I already did this. Let me change this. I made a mistake here. So let's do f of z. Okay. So this I already did this. I already did the condition. I selected the material aluminum, did the fixed support on these two holes. Change the weight here. See, I'm applying f of z on this face. This is the z face. I'm applying the force here. Click OK. You could also watch some tutorials on YouTube though for same skill, some static support, static simulation, same skill. Then I'll click the mesh. So I want to click. Usually you have to create a new mesh, but I've already created the mesh before, so I'm not going to create it again because that takes a while to create the mesh. So do standard. I want to do a standard automatic coarse. So means that coarse just means that this is more spaced apart, only closer to the edge. Is it like only closer to sharper edges? Does it like have smaller point? This is just to show in case there's like there's more stress. There's usually more stresses on area that have like sharp edges, places that are non-continuous areas. So usually more stress there. So that's why this has like more mesh, has like a more finer mesh. Then here we'll create a simulation run. Okay, let's create another run because the first one we did. Okay, so we'll create the run. So we start the run. So what it does now is just it's calculating all the force that has been applied to this and see if this is good. Should be just summarizing that. Once this is done, I'll just show the post-processing. So usually to fill this out, you just literally just go down the tree and put in each information one at a time. The only part that might be a bit confusing is the support. Just remember that this is fixed support and you're applying a force on the top. Then the mesh, just use the automatic mesh. You don't have to change any of the settings there. Okay, it's almost done. Then just so this takes a time. This takes a while. That's why sometimes when you let me even just mention that when you're creating the mesh, the finer mesh you have, the longer it takes for it to process. So yes, sometimes you might want to show a lot of mesh, but that also can take a while to process. So post-process results, just click on that after the run is done. Okay, so I'll just use the left mouse to rotate. So I'll click on the results. What do I want to see? I want to see the von Lee stress. So I'll click on this. So you see, so if I double click on this arrow, this here, I could change. So I change this to manual. So I could change the range. So everything, so basically this is just telling me where is the majority of my forces being applied. If, for example, I'm like, okay, I don't want this to go more than this certain amount. If it goes more than this certain amount, after I do my factor of safety, I don't want it to go more than this certain amount. I can see that a lot of this part is still blue. The parts that are still blue means that I don't really need those parts to support it. So I could do post-processing and literally want to redraw this and take all those blue parts out. So that's the majority of this. Sorry, I couldn't get into more detail into this, but that kind of concludes my session. Adi, do you want to take over?
Yes, I can do that. Thank you so much for all the work you've done today. Guys, I hope you've been exercised properly. And to everyone who is new to CAD design, welcome on board and congratulations. I hope you've been able to at least get yourself a design. And one of the reasons why we chose a platform that is free is that we want you to be able to practice this on your own when you get home or when you're relaxing. We don't want this to be the only time that you get to hear about design, because the world is evolving and we're getting into an era where if you're an electrical engineer, a mechanical engineer, material engineer, just having that knowledge of design is something that you can at least utilize sometime. All right, so I want to move on now and talk about 3D printing. So I promise you're not going to get into anything CAD design today again. But before we move on, if you have done any of your design, we would like you to tweet at us. We want to see your design. We want to see what you have done or achieved in the last 2.5 hours. It will be a pleasure to look at it. So please put it on your Instagram, your Twitter, your Facebook, so we can appreciate the work you've done in the last 2.5 hours. Great job. So I'm going to Present, God help me. I hope I can present.
I should stop sharing. Sorry.
Yes.
Okay.
Okay, so present now. A window. Okay, can you see my screen?
Yes.
All right. So, as you all know, my name is Dr. Adeola Olubamiji. I am Nigerian. I am a technical advisor, an advanced manufacturing technical advisor at Cummins. And this is a bit about me that you need to know. I have done 3D printing now for, I think, 11 years. And I got into 3D printing right almost at the end of my MSc, my Master's of Science. I hold a Bachelor's of Science in Physics, Master's of Science in Biomedical Engineering, and a PhD in Biomedical Engineering. So I am the founder of STEM Hub Foundation, and I really do love traveling the world when I have some time. So here are some things that I'll be sharing about today. I'll start by talking about the Industrial Revolution and where we're at and how we evolved to where we're at. Then I'll talk to you about what 3D printing means. I'll also now share about the different 3D printing technologies, the value proposition of 3D printing. I'll also share about the 8 steps, the 8 basic steps that you need to know for different additive manufacturing processes. These steps are mostly valid. And lastly, I'll talk about design for additive manufacturing. You've learned how to design a part. Can you manufacture that part using 3D printing? That's a question that we need to all answer, right? So, I don't know. Can you see me? Do you need to see me? You don't need to see me, right? Okay, so moving forward, I want to talk a bit about the Industrial Revolution. So in the late 1800s, we started Industry 1.0, which basically means that we at that point, they were able to safely manufacture steam engine. We have a little bit of mechanization starting up. And it was very interesting, especially for farming, because we could transport good from one place to the other because of the steam engines. That was a very good progress in the late 1800s. Then we move on to the second industrial revolution. And what this means is installation of assembly lines. So we can mass produce different things from cars to food and so many things, packaging food and all that. So Industry 2.0 was what brought us that mass production type of technology. 2.0 also brought us electric energy, it brought us an electricity. Isn't that awesome? So during this 2.0 period, we had electricity. We had like landline type of phone. And so things were really picking up for our world. Isn't that awesome? Then 3.0 is pretty much where we are leaving 3.0 now and moving towards 4.0. So during 3.0, Industry 3.0, we had automation. We have introduction of computers. These computers are big and now they're becoming small. All of those happens in 3.0. We have more electronics being made. We had TV, radio, everything was moving also to flat screen. So most of this industrial revolution takes about 50 years. So it will start and then it will keep moving. It will move for about 50 years. So in the 2000s, when we clocked the millennial, we're still in 3.0. And recently, I'd say maybe a couple of years, so maybe 3 years, so we started talking about 4.0. Usually there's a little bit of merger. If we're moving from 3.0, we're gonna slowly just move. We're not gonna get rid of 3.0. So that's what we'll have right now. We're moving slowly into 4.0. So 4.0 is building on top of 3.0. So in this chart here, I'm showing you what does Industry 4.0 mean. So it means that we're gonna have increased connectivity where your phone is gonna be able to communicate with your fridge. You can talk to Alexa to turn on the TV and turn on the light. You know, this interconnectivity is going to be greater. It's going to be bigger than what we're used to. It's not only going to be functional in our houses, it's going to also help us with the industrial work we do. So where you can speak and control so many things that are working in the factory without having to even touch them. which means that all this information will help us to increase productivity. That's what we're hoping. But in the process of us talking to something and it's moving around, we're going to be generating a lot of data. So a lot of those decisions that we're making on the fly, some of them will be based on machine learning algorithms. So those data are being crunched and artificial intelligence is being used to make those decisions without us even participating. So what this means is that we're going to have to create new business models. So in the past, let's say on your shop floor, you need 300 people to do a certain job. With this type of industrial revolution, the number of people that you need may cut to 15, and machine may be doing a lot of those work. Robots may be working alongside people and doing a lot of those work, and that will give us new business models and collaboration. Human beings being able to effectively interact with computer, with robots, with all of these different things. So we group this fourth industrial revolution into the following categories: cybersecurity, augmented reality, Internet of Things, cloud computing, big data, autonomous robotics, simulation, system integration, and lastly, additive manufacturing that you will be hearing about today. So, you know, sometimes you've heard me talk about this industrial revolution because it's very critical. Each of you on this call today could find a bit of all these different areas. You can find a bit of it and apply it to your work. I'm currently doing additive manufacturing, and I'm still interested in data analytics because, hey, I'm creating data. I need to know how to analyze those data. My additive manufacturing process, with the help of robots, it's going to be faster. So all of these different technologies are going to definitely communicate. So we can always learn a little bit of each of them without going too deep. So moving on. Oh, this thing is making noise. So moving on, let's talk about additive manufacturing, which is popularly known as 3D printing, which is why we're here today. So additive manufacturing refers to a process where you take a CAD design, such as the one you have created today, the 3D design, and you would use that 3D design to build a component in a guided layer by layer manner. So you may deposit layers of different materials, and then it starts to build on top of one another. If you look at this video that is playing, is the video playing? I need this video. Okay, I don't know why the video is not playing. So let me see if this second, okay. So this one here, the second one you're watching here is an example of an additive manufacturing process. I don't know why the videos are not playing. Are you guys still here with me? Okay, so, yeah. All right. I'm trying, I don't want the noise. It looks like if I leave the noise, it plays. I want to show you. Okay, you guys will just have to bear with me about the noise. Okay, so this one is playing and then it stops. God. This is ridiculous. All right, so I'm just going to explain through it because it looks like the videos don't work. So the first process on the left, which is the machining process, is a subtractive process. And what this means is that it's a conventional technology type of process. If you're trying to make a part using a subtractive method, you'll take a block and then you will machine out your part. So you've created a 3D part and you want to make that. You load that into your machine, and then it slowly cuts out your part, which means a lot of waste usually get generated in that process. But for the 3D printing one, it's a layer by layer manufacturing process where instead of you dumping a lot of things there and tracing out the part, you just need your material to be put in the right place. So you use less amounts of materials when you are 3D printing, and you don't waste a lot of materials, pretty much. So this technology became a lot attractive to manufacturers because of the fact that you save when it comes to waste, and it also helps you with some very good things that I will talk about in terms of complexity, durability increase, and so on. You know, I touched it, now it's moving. It stops again. Okay, it's not gonna, sorry about that. The video is not going to let itself play. All right, so let's talk about the adoption timeline of additive manufacturing. So additive manufacturing started in 1986 when the first patent was issued to Harlan Lemahu and Chuck Hall. So these two men were the four founding fathers of additive manufacturing, and one of them, Chuck Hall, he went ahead and founded 3D Systems, which is one of the manufacturers of 3D printers today. So the work that they started in 1986, one of the two people did it beyond a laboratory project, and he actually started making money from it by creating a company that now makes 3D printers. And as you can see in the graph on the right, 3D printing, the rate at which it's growing is exponential. So in 2013, the value of this industry was about 3 million or 3 billion. And it's growing and growing and growing crazily. From 3 billion, we reached 7.3 billion. And the way we are growing, it shows that very shortly we'll get to 30 billion, I think by 2022. So what this means is there's a lot of potential here. There's a lot of growth, and it's a very exciting time to be in this field. And that is why somebody like me decided that this is where I want to plant myself. On the picture on the right side, you can see some of the industries that started adopting additive manufacturing when it started in 1986. We started by using it to prototype. And what that means is if I want to make a real part and I want to mass produce it, before I mass produce, I can make one piece of that part, that's a prototype, and be able to present that prototype to my team, explain to them, this is the part I want to make 2 million pieces. Should we change the design before we start to make it? You do that a lot with 3D printing in the beginning of 3D printing as a technology. Over time, we have evolved from just prototyping to moving on into now, there are places where 3D printing has been adopted for production. And some of the areas where we have used 3D printing when in the beginning were concept design, product design, and whatnot. But now we are using them to mass produce engine components, especially for aerospace and biomedical applications. You may wonder, okay, I've heard about this 3D printing. Is it that tabletop printer that you just buy and I can buy one? Yes, that is one of the 7 technologies available. So what I'm showing here is to let you know that you may have been hearing about 3D printing. 3D printing is not one single technology. There are 7 different processes, 7 different technologies involved here. The one that is pretty much very known falls under the material extrusion. If you look at the material extrusion, it's like a molting type of 3D printing. A material is melted and then it comes out of a nozzle to form the layer by layer process. We have the powder bed fusion, which uses powder, a discrete material. You put the layers of powder down, layer by layer, and you introduce a source of energy. That could be laser, that could be electron beam, it could be different things. And then binder jet technology, which also uses powder as a discrete material that is laid down, uses what we call binder, which is like glue. So one layer is put down, you put a glue, then you put a second layer. You may be wondering, so I just dump the glue? No, you don't dump the glue. We call the process selective method. So the glue is dumped in the areas where your CAD drawing has told it to go. So the glue will just be dumping based on your CAD drawing that you put in or CAD design that you put in, the glue will be poured in there. Direct energy deposition, sheet lamination is one of the interesting one for me because it's like it uses, you know how sheets of papers are. It just puts one sheet down, it puts glue, puts another sheet down, puts another sheet down. It's like sheets of papers being glued together to form a component. Material extrusion, very similar to binder jetting. Put material down, put glue on top of it, You keep gluing it like that together until you are able to form your entire part. And polymerization, in this case, is liquid. So it uses resin, which is a liquid, and then you shine maybe UV light or whatever light you want to shine. You shine it on that resin, but those lights are shown in the places where your design said it should be shined to. It just doesn't shine randomly. It follows the pattern from your design. So here are the seven different processes that are out there, but each of these processes have sub-processes. So one process could have other sub-processes. As you can see here, for the polymerization, there are 3 categories under polymerization. For powder bed fusion, it has 3 materials, and there's still another subgroup. What is this telling you? There are so many opportunities in 3D printing, because you can decide to learn 2 of the methods, you can decide to learn 3 of the methods. You know, you can't go out of job, because there are different types of methods that you can keep learning. So this is one of the reasons why I love this field, because it's exciting. There's so much to learn. You can get 7 PhDs in 3D printing if you want, because there are so many different new technologies that are out there. If you look at the picture very well, the last part of the picture show you what type of material can each of these technologies print. So for the VAT polymerization, it is used for plastic, because we are talking about resin being cured by UV light, right? Resin is usually a chemical compound, and then you shine light and then you form a plastic. So that's a strictly plastic related process. For material extrusion, you can do composite and plastic. For metal jetting, you can manufacture plastic, metal, and wax. You know, just moving forward like that. Some of these processes you use for plastic, others you use for metal, some you use for composite, some you use for wax, which is pretty much almost plastic. I hope this is making sense to everyone. I want an answer. Do I
Yes.
have you guys there?
Yes.
Are people still here? Okay, I think you.
We're here.
All right, thank you. I just want to make sure I'm not talking to myself. Sorry. All right, so yeah, moving on. And as you saw in the last slide, I was explaining the different types of materials available. So we talked about plastic, metal, and ceramics. Here, I'm showing you more detail about what type of plastics. If we're talking plastics, is that technology able to take thermoplastic? Are they photopolymers, type of polymers? Can they use biomaterials, which is used in human body? And is it multi-material? Can I make 2 or 3 materials together? Some of these technologies allow you to make multi-materials, so you can have 2, 3 materials being made together. Some of them is just single material that is possible. Some of them you can use to make biomaterials, so those ones will be suitable for biomedical related applications. Some of them you can't. So while you think through, okay, if I needed to use 3D printing for something, this chart is to let you know what are your options based on the 7 different technologies. So you don't think, you have to make sure you know what that process can do and what type of materials it can use before you select that technology as the technology that is right for you. We're going to do a bit of brain teaser when we get there. Usually when I present about 3D printing, people ask me, so how long does it take? If I want to make a cup, 1 cup, how long will that take? So this chart is showing you how the speed of each of those different technologies we talked about. So here it's showing you that FFF seems to be one of the ones with the lowest build rate, and binder jet is one of the ones with high build rates, like it's faster. So depending on throughput, because especially for manufacturing, in some cases, our manufacturing capability could be small. You may need, for a particular part, you may need 2,000 parts per year. But for a particular part, you may need 2 million parts per year. So before you choose the technology that you want to use, you have to make sure that the build rate is going to favor the type of volume that you are looking for. If you're just making 1 or 2 parts, that's not a problem. But somebody commented on when I posted this on Instagram, somebody commenting that it works for a company that does 3D printing of some nylon, and they make millions of those. So if you want to make millions of something and you decide that you want to use FFF, that could be really slow, right? Especially if you need a particular amount in a particular time. So really understanding the build rate is one of the things that people like me try to know, so that when people are saying, I want to 3D print something, you can effectively guide them to the right method. All right, so you may be wondering, why fix something that is not broken? If we already have technologies that works, they all work, we've been using them for 50 years, everybody is fine with them. Why should we change to 3D printing that we don't know? Why do we need something fancy if the one we have still works? The reason for that is because we want to expand what is possible. And we are also trying to rethink manufacturing. And what does that mean to you if you're trying to rethink manufacturing? So normally when you want to make a prototype for a part, especially a part in manufacturing that you may want to be producing millions of it in later, those prototypes in the past, you need to first you will make a mold. You make a mold for what you have designed, and you now make a prototype. Some of those molds could be costly. It could cost you $10,000. It could cost you more, and it could take weeks for your mold to be ready for you to now make one prototype. You may now take that prototype to your design meeting, and in design review, they tell you that the prototype is not good enough. Go back and redesign the part. So you've wasted $10,000. You've wasted multiple weeks, and now you go back and redesign. What if you come back again and they say it's not good? You have to go back like that. So product development has been a lot slower due to conventional methods that we've been using. But with 3D printing, because we don't need molds anymore, you just 3D print the part. Once you design it, you print it, you take it to design review. If they say they don't like it, you go back to your design tomorrow, you change the design, the same day you can put it in the printer and start printing. So that is why it's called rapid prototyping, because it makes your prototyping fast. So this is one of the benefits of additive manufacturing, and this is one of the reasons why a lot of people in manufacturing are moving towards that. Another one is part consolidation. Here I'm showing a GE part, General Electric's part. So this part used to be 300 pieces. 300 pieces of part being made, and then we will now bolt it together, we'll weld it together, and it will become one part. Now that 300 part is being made as a single part using additive manufacturing technology. Isn't that awesome? So instead of manufacturing 300 parts, you manufacture one single part at a time using 3D printing. What this means is if those 300 parts, maybe you need to weld them. Now you don't need welding anymore. You don't need those welded joints anymore because they are all made as one single part. Maybe you needed to bolt them together. Now you don't need that extra bolt that can increase weight. You don't need that anymore. What that is doing for us is helping us with weight reduction, because now you have merged all the parts, no weld area, no bolt. So weight reduction is one of the good things that come out of part consolidation. Another thing is durability, because when you weld parts together, those areas can also be your crack initiation point. If any crack is happening, that could be the first place that will crack, because you weld the two parts together, and mechanical properties at joints are oftentimes the weakest. So with this, we've been able to have better durability. So parts that used to last for 5 years, we now see them lasting for 10 years, for 12 years. In some cases, we're seeing them even lasting longer than that. Performance improvement, because now you have 300 parts as one part. In most cases, when something is lighter, especially in aerospace, it could enhance its performance. And performance could be in terms of fuel efficiency, because lightweighting of anything in the aircraft help you manage your fuel properly. Aircraft fuel, they are expensive because there are so many calculations that go into it. So part consolidation has been one of the biggest reasons why additive manufacturing is being adopted. Mass customization is another one, especially for the medical devices, medical industry. You know, my knee size can be different from Johnson's knee size. So if I have osteoarthritis and they want to replace my knee with an implant, they have to make the one that will fit my knee. One size does not fit all in medical. So being able to do fast customization of implants is one of the reasons why adaptation of 3D printing is becoming really popular. Not just knee. Here I'm also showing teeth aligners that are being made in plastic. Everybody's teeth has different shapes, and we can't use the same aligners. So this is helping us to create customized products for people, not only in medical. You've seen a lot of times where in fashion shows, they 3D print outfits, they 3D print earrings, we're 3D printing anything 3D printable these days. This technology, because of ability to mass customize, is really taking off. Aftermarket supply. So you bought a car. That car is a 1997 Corolla. So the crank shaft now have problem. Now Toyota now said they have discontinued the part. They don't make the 2007 crankshaft anymore. Maybe because people don't really have the 2007 car anymore, so they may discontinue it. But what this is helping us is, for those parts that we feel like we don't need to keep this stock for so long, we can 3D print them for our customers to be happy. So our aftermarket business, 3D printing is really, really working in that area. In fact, Cummins, I put a Cummins part there. That is one of our aftermarket parts that we weren't producing anymore. Our customers need them. We just 3D print this part for them on the go. Whenever we get a request, we print it right away. We don't need to keep the parts in a place and be paying electricity bill for them there, right? Then lightweighting. As you can see in the picture here, a lot of time when you machine a part, the part will be big. It will look bulky. But with 3D printing, we can reduce weight. What Johnson was presenting that I rushed him off of, simulation. So when you run your simulation, you can look in your parts and you can see that some area in your parts, they're just blue. They're not carrying any load. So the load is not affecting those areas. They're just redundant. If you've done your simulation and you realize that those areas that don't carry load, you can let them go. You can cut them out. You reduce the weight and you are able to 3D print a lighter part. And in some cases, these lighter parts can be very complex. As you can see here, we have heat exchangers that we now 3D print with lattice structures on the internal side. We have conformal cooling channel, as you can see. These are things that you can never do in machining. You can't machine a heat exchanger. You can't have this type of complex structures done without 3D printing. So there is a whole lot of value proposition that is making 3D printing the technology of importance. Well, I'm going to have to move on from this slide. I wanted to show you guys some of the lattice structure opportunities that are possible and talk through this part, how they were able to reduce 60% of weight and surface area increase times 10 because of the lattice structure, and the cooling process is 10 times faster. That is a good improvement that they've done. And this work was done by Fitwest. Okay, moving on. Here are the 8 steps. So if you want to 3D print any part using any of the technologies that we talked about early, here are the 8 parts you have to work on. So let's say you have finished designing your part that Johnson asked us to design. You have run your simulation. Now you felt like, I need to remove this area that are redundant because when I apply my load cases, I realized that this area could go. So you will have to redesign that part for additive manufacturing by removing, you can remove some of the weight. And in some cases, if everything Johnson made today, you normally in machining, you can't machine everything together. But in 3D printing, I can print those 4 components as one piece. So I can just make them together as a piece. All I need to do is I will merge the 4 parts into one part, and I will remove some areas, I will fillet some areas, and I will make that part printable using a particular 3D printing technology that I have chosen, and then I'll move on. So design is not done when you finish designing your part. When you want to do the part, you want to print the part, you need to redesign it for additive manufacturing, considering all the tolerance, all the different boundary conditions that 3D printing has. Because if you don't, that part it will be too stressful. You may not be able to print it. So I wanted to kind of share that. Conversion to STL. Johnson also touched on that when he was talking about mesh creation. So when you finish making your original CAD file, you have to convert it to a language that 3D printer can almost understand, and that is your STL file. So once you convert to STL, sometimes those meshes that he created, they may be touching each other, and your part may have some meshes that are not right. So you may want to kind of adjust that a bit, but yeah, you convert to STL, you do your build preparation. In 3D printing, you can make more than one part in one build for some of the technologies, but for some, you have to make one part at a time. So for those ones that allow you to make more than one part once, more than one part in a build, you have to do a build layout where you nest the part. I'll explain a bit more. You set up your machine, you print, and after you print, you have to break it out. You have to remove your part, you clean your part, you post-process it, you measure it to make sure that what you said you want is actually what you printed, right? You want to make sure that you got what you wanted by doing some measurements and making sure that the mechanical properties that you predicted in your simulation is what you achieved. Boom. I'm running really, really fast because I don't have a lot of time, but I try and see how far we can go before the 3 o'clock. I don't think we can go too far. So I talk a bit about design for additive manufacturing, and I want to clarify a lot better here. So if you've designed a part, you want to make sure that that part has the right type of things that will make it 3D printable. I'll just move on. So if you're thinking about a part that you have created, and now you're thinking, should I 3D print this part, or should I use machining for this part? This is how you would decide what is the right technology that you should use, whether it's 3D printing or is machining or is anything else. Then this is also how you will be able to know which 3D printing technology is right for me. So this chart here help you understand, okay, so I put here some of the things that drives your decision. So you need to know, okay, how much do I have allocated for this project? If you don't have a lot of money allocated for this project, how much is it if I print this part in FDM? If I want to do fuse deposition modeling, how much is it? And then you think about speed. We talked about speed earlier, that some of them, they are very slow. Some of them, they are very fast. If you don't have a lot of money, definitely you are looking for a method that is fast. Part size. So every 3D printer has what they can make. They cannot make what is bigger than their build envelope. So you need to know, for the technology that you want to choose, what is the build envelope size? Will my part fit in? How many of these parts can I put in one build? Does that match my costing and my business case in terms of the money that I have? Then you think about part complexity. If your part is very complex, it has lattice structure, automatically you can't use conventional method, because conventional method cannot build those lattice structures. So you are looking at 3D printing. Then you need to now decide, okay, do I need plastic? Do I need metal? If I need metal, which of the metal 3D printing technology can give me what I'm looking for? So this is just a guide for anyone who is thinking, I want to do 3D printing. This will help you with selection of the right technology. I wish we have time today. I would have loved to do this as a brainstorming exercise where we all pick something and talk about it. But unfortunately, I have to move on. So here are some of the things that we always consider when we're choosing 3D printing technology, especially for metal 3D printing. So you want to make sure that you understand that, okay, if you have selected and say, I want to do laser powder bed fusion, you need to know what is the smallest thickness that this technology can print? Can it print 20 micron? If your lattice structure is 20 micron, if you can't print 20 micron, you have chosen the wrong technology. So with these design guidelines, you are accordingly guided to the right technology. This helps you make a choice in terms of what technology you should use. Also, there are a couple of things. This is very specific to laser powder bed fusion, though, but not all the technologies require this. But for laser powder bed fusion, it is very angular specific. If your overhang is less than 45, you will need support structure. So in a lot of cases, we try to orient our parts such that there is a greater than 45 angle when you put the part on the plate. I'm really going to have to rush. Oh God, I don't like keeping you guys here extra. Or can you guys stay for another 10 minutes? I need an answer so I'll know whether I can finish it today.
Yes, I can.
All right, so I can keep going?
Yes, you can, Dr. Adi.
Right, thank you. Okay, so conversion to STL. So when you have made your part in CAD, such as the one you have made, and you're converting to STL, what I want to share here is on resolution. Johnson also touched about this slightly. If the resolution, you can see these O-rings here, you can see the resolution here for your mesh, is very fine. The resolution here is not as fine. So if your resolution is not as fine, this could affect the quality of the part you will make. But if the mesh is also too good, sometimes your part will be too, when you send it to the printer, it will take a while to upload to the printer. But I always advocate for finer mesh because you want your part to be smooth on the surface. You don't want it to look like what you can see here, where if you're trying to, it just shows you like angles that are not supposed to be on your part. So using the right resolution is very critical. And when you're saving your mesh, sometimes when you're saving your STL, sometimes you may have what you see here. So your STL could be slightly damaged and it may need repair. If you don't repair such an STL, your printing, when you finish printing your part, you can see a certain hole in some places, or you can see a little blob in some places. So you need to, after you finish designing, convert to STL, you need to check your STL to make sure that your STL doesn't have problems, because if it does, this problem will reflect on the part that you have created. And moving on, so once you've done, I wish I could do some experimentation, but I just thought you guys have been tortured with over 2 hours of design. I didn't want to continue to torture you guys. But when you're trying to print anything, before you send it to the printer, you need to do a build preparation. So a build preparation helps you to be able to put multiple parts together on a build plate. What you see here is a loaded build plate that has over 100 parts all together. So this is what you do when you're in production. When you're trying to make maybe 2 million parts, you want to make sure that you nest your part appropriately and use every space within your build envelope. But if you're trying to just run a prototype, you want it to be as fast as possible. So if you look down here, you'll see on orientation, you can select based on what you're trying to do. So if you're trying to do something fast, you can just put it flat like this. So it will print very fast. Everybody will go to their house. But if you're trying to load a couple of these same parts together on the build because it's a production part, then you have to stand it upright. What are the criteria that you need to consider before you make a choice in terms of what is the orientation that I want to print in? You have to, first of all, think about how fast do I want to go? Secondly, amount of support structures. The things that you see in red here, they are called support structures. For some of the processes in additive manufacturing, you need support structures to hold your parts to the build plate. Some of the processes don't require it, but for those who require it, those things are going to be printed in a material. So it could be a metal, it could be in another, if you're printing in polymer, it could be in another polymer. But these are not stuff that you can easily remove. So you are printing something, metal, and this is the part you want to print. So oftentimes you have to think it through. If I finish printing, will I have to go and do machining? Because here, for the one that is sleeping flat here, you can see it has support structures everywhere. So when you remove this part from the build plate, you have to machine out the support structures, and you have to spend a lot of time cleaning up that part, because the surface area covered by support structures is a lot. Whereas the one standing up, it only have support structures in some places. Yes, you still have to break it out and clean it up, but the work you do on that is not a lot. Post-processing is reduced. So for any designer who is doing additive manufacturing, you must consider your support structures. It's very critical if that technology requires it. Another way to predict whether what you are going to whether what you have designed is going to print, and whether your support structures is enough, is running simulation. So here I'm showing an example of a simulation that can be run. So this is one part, the orientation slightly changed. You can see the red area. Those red areas are areas where you're going to have residual stress buildup. So those parts in those areas, it could break during printing or after printing. Those areas are susceptible to residual stress, and it could break. So when you do your simulation help you understand whether you don't have enough support structures. You should reinforce this part with more support structures before you send it to manufacturing. So with simulation, we are able to make good prediction about our process capability. We're able to adjust it before sending it to the printer, which is very critical, especially when you are trying to save money. That's why you came to 3D printing. You don't want to be making parts that are not printable. So you need to run your simulation to be able to accurately know whether you have enough support structures for those ones that require it. Moving forward, I want to talk about some of the processes that I think we may come in contact with. If someone is here today, you're thinking, well, I finished school, I want to start 3D printing as a little business. What type of 3D printing should I use? So I selected this one because it's one of those 3D printing technologies that you can use to launch a little business wherever you are. And I have a mentee who currently run a little business in South Africa using this 3D printing technology. So that's why I chose that I was going to talk specifically about this technology. It is called photopolymerization, and I mentioned it a bit earlier. So resin is put down, and UV light or any type of light that is working for that machine, it shines through that UV light, and then it starts to create the part. What you see here is a part being created, and the UV light is shown from under. The part is printed from on top. So this is like a reverse type of process. But what I like about this process, a couple of things. The first one is the resolution of the part. So if you look at the aligner that I'm showing here, you can see that it's smooth. So this is an aligner that you're going to put on your teeth. You can't have the resolution being poor because you're trying to use it to adjust your teeth. So this process produces very good resolution, but yes, it could be a little slow, but it's not really that slow. So it's the cost of this printer, I think, is about $3,000, and you can start to manufacture things that you can sell to people and make profit from. Very good technology, easy to install, uses UV light or LCD or whatever light or laser beam based on the technology that you purchase. But for anyone who is interested in yes, now I've learned how to design. Now I know I have some understanding of if I want to manufacture my design, some of the changes I need to make to be able to produce it using 3D printing. This is a method that you can now use to manufacture that is easy. You can buy the printer and start to produce something that you can sell to people. The second technology that is easy in terms of, I think this one is a video, yes. So the second technology that is very easy, and this is the most common additive manufacturing technology, is material extrusion. So it uses filament. Filament is its feedstock. It feeds in the feedstock into the nozzle or the printhead, and then it melts this powder, or sorry, it melts this polymer, and then it extrudes it out. this method is what you find everywhere. Literally, when you see someone having 3D printer in their house, this is the one they have. At the moment, you can even buy some of this FDM printer for $300, for $200. So a lot of hobbies makers buy this to try to learn 3D printing further. Despite the fact that it's being used by hobbyists and makers, it is also being used in the industries. A lot of people who have to make jigs and fixtures. So in manufacturing, we make jigs and fixtures that we use to assemble things. You can see here where someone is trying to install the name of a car. This yellow stuff that they put around this is a fixture. This is something that we use, right? So this has been 3D printed. And usually these are not things that are 3D printed. These are things that companies will buy them and they will keep them in their storage room. When you break one, you go and pick another. These days, that is not the case anymore. We use this type of FDM technology to just make them as we need them. Here is another example of such a fixture that Ford uses to put names on their car, or to measure to make sure that the names are aligning properly. And this is another one here. This white one here, white and red. This is also another fixture that is being used by Volkswagen to put to make sure that your tire is aligned properly. So this technology is very affordable. A lot of hobbyists are using it, but it's also being used in the industry for fixtures and jigs, and very, very easy, very affordable. So if you're interested in, I want to learn 3D printing a lot further, I want to be able to do my own build prep and make my own build layout and send it to a printer, this is the type of technology that you want to explore. With $250, I think you can get a printer. For industrial application, this is an example of what we use. And I chose this one because it is being used in repair. Back in Nigeria, you know, you buy a car, your what is that thing that is big in the your engine head? I've forgotten the name. The big engine block. So your engine block, as you have a damage. You don't want to change the entire engine block. You just want it repair. With this 3D printing technology, you can repair anything that is big but has a little bit of damage. So I think this is very useful for a lot of machineries in Africa, where some part of that machine may damage, or some part of a big component may damage, and you want a quick repair. This technology is being used for that. And as you can see, this part, you see how tall it is, the part that is being made. So you can use it to make a part, and you can use it to repair a part. And very good technology, easy to use. You can even still see how much of a material you save, because you are not putting material where it's not needed. The material is being poured down in a way where you precisely put down the material that you need. No waste whatsoever. So this technology enables you to save cost. It enables you to reduce a lot of waste. And hey, if your part is damaged, easy, you can repair them. So good for anyone who is thinking of, I want to start a 3D printing business in Africa. I'm thinking about where is it I should be looking at. I think there are a lot of machineries in Africa where big components are damaged, and because there's that damage, now they're looking for a welder. The welder didn't do it properly, all of those things. This technology can literally take the jobs of those welders easily. Moving forward, sheet lamination. So I wanted to talk a bit about this one because it's one of the weirdest 3D printing technology we have, but it's very good for making electronics. So with this technology, you can have multi-component kind of fixtures being made. So you can put electronics inside a casing and 3D print everything in a go. So if someone is thinking, I want to make a nano electronic, I'm thinking about developing a device that will stay inside a case, and I want to make everything in one single process, sheet lamination allows you to be able to do that. And as I talked about earlier, it lays down the sheet, it puts a bonding glue, and you just watch the video. Puts down the sheet, a bonding glue, puts down another sheet, a bonding glue. So there are two technologies for that. And I think for anyone in electronics looking at 3D printing, this is a technology that could work. So it's either you're using a laminated object method or the ultrasonic method. Both of them works great. Here are some of the materials that it can make. I think I have overspent my 10 minutes, but so if you ask me, what is the most common 3D printing technology used today, apart from the FDM tabletop one? The most common one that we use in the industry is the powder bed fusion technology. So powder bed fusion technology are subdivided into 4 categories. The ones that we use a lot, we use the SLS, which is for plastic. You manufacture plastic with it, such as what I'm showing here, and you can nest the plastic, so you can have 200 parts together within one build. So for anyone who is looking at, I want large scale plastic production for Africa, you can look at SLS as a very good technology for that. Then we have the selective laser melting, which is what is showing here. So selective laser melting is currently the technology that people like BMW, GE, all of them are using to manufacture components that they've been able to send to space, or components that are flying in their aircraft. It is the most dependable additive manufacturing method that we have today for metal manufacturing for industrial application. It uses metal powder deposition and laser light to do the job of making the part. Very, very good for both low volume and high volume. This method is also what is being used a lot for implant manufacturing. So if you're looking at hip implant customization for people, this is the right technology that is being used. So that many opportunities there. There is the plastic opportunity and there is the metal opportunity. Is this technology expensive? The metal one is sophisticated. It could be slightly costly. The plastic one is very reasonable. So for plastic application, low cost, I recommend this method. Moving forward, so I put here a chart to let you just be able to think through. If I need to manufacture anything, if I need to start a 3D printing kind of work, what do I need? You need your design. You need to be able to manage your system, which is when you buy a machine, you need to know, how do I service my machine? How do I calibrate my machine? How do I qualify my machine? Making sure my machine is working. Everything falls under system management. So powder, I should call it material management, because you may not use powder, you may use filament. So material management, being able to know, if I buy a material, how do I check if the material is good quality, is what I can feed into my machine? Being able to know that is another thing you need to know. Then process development. When you buy a machine, they give you a print parameter, a standard print parameter, and say, if you melt your polymer at 200 degrees C and your speed is 20 centimeter cube per cc or whatever, it will tell you that you are going to be able to make a part. If you want finer features, you can now start to play with your parameters to be able to get finer features. To be able to know your printer very well, you need to do your own material development or your own process development, so you can print whatever you want, the way you want it. Maybe you want it better than what you bought as the standard. Post-processing. Most of these technologies, you need to break out support. You need to clean the part. So being able to understand what are the post-processing steps that I need to know. You need to have a process established for that. It's not hard, just know what you need to do. Lastly, automation and facility. Where do you want to keep the printer? Do you want to keep it in your house? Have you established an area where you can put it in your house? Do you have the right temperature there, if it's temperature dependent? Do you have everything you need? Just plan for that area. Your machine is going to produce data, because as you 3D print, data is being produced. How do you analyze your 3D printing data so that you can know if your machine is behaving well or not? And every other thing in terms of, okay, supply chain, if somebody is ordering parts, how can they order parts? How can I deliver parts to them? I put this together just for people who are intending to get into, I want to start to do a little bit of process, and I want to make money from 3D printing. You need all of this process established before you can start to make money. All right, so here are different industries where we currently use 3D printing today: biomedical, aerospace, architecture. So for architecture, we're seeing a lot of 3D printing being templates, where they do their blueprint these days, instead of just showing papers, they will bring you the model to meetings where they want to show you how your house is going to look. Automotive industry, consumables. These days, people can make earrings using 3D printing. They can make different glasses. They can, Nike, they're Adidas, they're making soles of shoes. So many things are happening in 3D printing. And we are creating a lot of entrepreneurs. And I want to encourage you, if you're here, you're a mechanical engineer, you live in Africa, you're complaining that you don't have a job, you can start your own product development entrepreneurship journey by starting a bit of 3D printing. Buy that machine, start a little business. If you want to talk further about that, come and chat with me. I want to see makers from Africa becoming entrepreneurs and really taking 3D printing to the next level. I mentor a couple of people in South Africa, in Canada. I really have not been able to mentor somebody from West Africa. So please get up. There is opportunity, there's money to be made. And lastly, so if you're on this call, you are wondering, I don't know exactly, you saw I'm a design engineer. So what should I add to my portfolio if I want to switch to 3D printing? So I put this together for anyone who fall under these different categories, so they can look at the skill sets they need to add to their portfolio if they are looking at crossing over to 3D printing. All right, that is the end of my story on 3D printing. I would have loved to do a little bit of practical today, but I felt like you guys were really flogged for 2.5 hours on design. So are there any questions that anyone have that I can take? Any question on the call?
Hello, I have a question. Hello, can you hear me?
Yes, I can hear you now. Okay,
good evening. Thank you very much. So basically in Africa, one of the biggest problems that that's in industries in Africa have is that their machines that they use to run their processes usually gets broken with time. And most of the time you cannot find quickly some of these parts. And I think 3D printing is a very good option to actually quickly replace and repair any sort of problems that you're having with these machines. What type of machines would you recommend for these machines that require parts that need to be replaced quickly? Because most of the time they are usually metal parts, steel, brass, bronze, aluminum, sometimes stainless steel. That's my question.
I think this is, I missed out. I didn't go through the chat that can help you determine what technology you can use based on what problem you have. But I'll make sure that maybe send out the slide so that people can look at that. But straight, some of the methods that can be useful for you, like, I think it depends on the size. If the part size that you're dealing with is small, and if it's just, I want to repair it and whatnot, direct energy deposition can be used for small or large part. But if this is a part of the entire part is what we need to make. It's not like we need to repair. We're not repairing one side. We want the part made. Then you want to consider laser powder bed fusion, also called selective laser melting technology. Now, because you're in Africa, selective laser melting machines, they are expensive, but they are selling the small scale of those machines. So companies like GE, they have MLab, which is a selective laser melting machine, but it's a smaller piece of that. So we need to consider what are the normal sizes of this type of parts that you're talking about. If the sizes of those parts fall in the category that the MLab can make, then you should buy an MLab. I'm just giving MLab as an example. Renishaw also have their own small model. Everybody is having their own small model of SLM process. But if you're thinking, I want to be repairing like cylinder head, big stuff that are spoiling, then you want to consider direct energy deposition as a method. There's DMG Moore, there are a couple of manufacturers of direct energy deposition equipment that you can look at. But those two technologies, when you are considering metals and you are thinking Africa, low scale manufacturing, repair, you repair, think direct energy deposition. Low scale manufacturing of metal, think of selective laser melting, but think of systems that are small, like the smaller scale that are being made these days. Hope that helps.
Yes, I'll probably send you some message so we can have a talk about this after. Thank you very much.
You're welcome. Any other question? So you guys understood everything, it looks like?
Dr. Adi, thank you for the great presentation. I must say I was really touched by this. So I would like to know, please, how can one get a 3D printer shipped to Cameroon? And second question, what do you think is the future of additive manufacturing in Africa? Thank you.
3D printer shipped to Cameroon, it depends on which one you want to buy, right? So you have to identify which one do you think, are you just a maker, an hobbyist who just want to learn? If you are such a person, then you can on Amazon or in so many places, just look at those ones that cost like $200. I think they should be able to get it to Africa for you without any problem. Another thing that I want to say is General Electric has a yearly competition where people can compete and get free tabletop 3D printers from them. So if you're actually looking at, I don't want to pay for this, you can look on General Electric website, look at when they will do that competition, apply for it, tell them why you need that printer, and I can guarantee you they'll ship it to you in Africa. It will arrive in your house. And on what is the future of additive manufacturing for Africa? So today I didn't present areas of how you can use 3D printing to make figurines, which is so in Nigeria, for example, we go to parties all the time, right? We go to Owambe and people take pictures in front of Owambe. What if instead of pictures, they can do a figurine of you? A figurine of you with the clothes you are wearing, and you can take this home and put it in your house as your figurine that you made when you went to that party. And so that is something that 3D printing is recently doing that I feel like it is adoptable for Africa. So if anyone is thinking, I want to start 3D printing business in Africa, there are areas to it. So that's one area. Another area is we've talked about repair. We've talked about aftermarket business. We buy a lot of used cars in Africa. So all these used cars that we buy, their parts, when you need their parts, they will be ordering the parts from China. They say they're ordering the parts from Toyota. It's taking 2 weeks. You can now 3D print those parts in Africa if you have the machine there. You manufacture there and you give it to people who needs it. So that's a business that is waiting to happen for Africa. And if you have such a facility where people can send you their parts and say, my part is not working, we want a new one, and you can make it for them at an affordable rate, I think that is a business that is waiting to be created. Another one is 3D printing for housing. So I don't know if you've watched on the TV where they said 3D printing was used to make a bungalow and it's low cost and whatnot. That is an opportunity. There is a company called Winsun, and there are a couple of companies that are really using 3D printing to build houses. In Africa, I think settlements can be created that will be, those houses will be bungalows, 3-bedroom, 1 bathroom, and sitting room like that. Those type of work can be done using 3D printing. And today we have not tapped into it as a people. And we are the people that our population is growing. Africa population is growing rapidly. Where are we going to house those people? This 3D printing provides us an opportunity for low cost housing. And we are not exploring that. So many opportunities can be done. Customization, I talked about prostheses, right? So there are a lot of amputees, a lot of people that need augmentation of their hand, of their leg. You can 3D print prosthetic hand using FDM, those tabletop printers. You 3D print prosthetic hand for those people easily. Prosthetic breast for people who have gone through breast cancer, they've cut their breast off, they want a prosthetic breast. You can make that using 3D printing. Tons of opportunities for Africa that is not being tapped into. And this, I'm so passionate about it because I believe that there are youths on this call today who can start an African 3D printing business, not just as an hobby. You can make money from 3D printing by investing a little bit of your time, learning those little things on build preparation, buy the printer, know how to design for additive manufacturing, the business starts. So I can keep going on from making houses to figurine to prosthetic, so many different opportunities to repair. Africa has, we have those problems that 3D printing can solve, but we need the youths to go in, but we need some money given to them and some knowledge to get them started. Any other question?
Dr. Adi,
yeah.
I've seen 3D printed housing online, but they're usually like bungalows. Has like story buildings ever been made?
Yes.
Okay. Like how many stories? What's the highest story?
I think 5.
Wow.
Right? 5, yes.
Wow.
So it's possible. It can. The reason why I was talking bungalow is because if government is thinking of, we want to just build small house, we want to turn this place into a settlement, and we will just build small bungalows and we will sell it to these mothers that are selling things on the road for cheap. With 3D printing, they can do that. They don't have to subsidize. They can print those houses cheaper. So that's why I was suggesting bungalows. But they are already making 5 stories, and very soon maybe we'll have taller ones.
Thank you.
You're welcome. Any other question, or we close it here?
Dr. Adi, thank you so much for the answer. I was very impressed. And please, are there maybe some programs where if one wants to get maybe some further training in this discipline, coming maybe from a science background? Are there some programs I can recommend? Because I think you will need some kind of training in order to be able to run maybe a startup business. Thank you.
That's a tough question. There are some. I haven't seen anything that is that is good enough. Maybe I should even create like a course. I've been thinking about it, that maybe I should create a course and make it an African. All my case studies will be African related. Let me search. I can do some search for you and see what I can find. But I also would like you, if you can write to me and tell me where your interest lies. So maybe if you tell me the interest, so when I'm searching for those courses for you, then I'm really searching based on your interest.
Okay, thank you so much, Doctor.
You're welcome. Okay, so this is it, guys. I hope this helped. I'm sorry that I had to rush through a lot of my slides. I wish I had enough time, but I hope that helped in some ways. I'm very thankful to all of you for staying with us, for participating in a whole lot of different things that we have done. We really do hope that the 5 weeks and the other ones that you've got seen from us, we hope that this help you with some clarification of the Industrial Revolution, the 4th Industrial Revolution. This is coming to us. As Africans, we don't want to be left behind again. For so long, we have been at the tail end of innovation. We have been at the tail end of knowledge. This is an opportunity for us to not be behind, because this is new to everyone around the world. This is an opportunity for us to plant ourselves in the forefront of innovation. Some of you know me. Some of you know some of my stories. I work for Cummins. My current position, they do not give it to people with less than 20 years of experience. I do not have 20 years of experience, but I know 3D printing. And because the technology is new to everyone, nobody has 20 years of experience. So they have to give it to the Black girl with an accent. And I want to challenge you, if you're listening to me today, it's not only 3D printing. We talked about those different other areas under Industry 4.0 that are new. Please get up, get on board with one of those technologies, teach yourself those things. And I really do hope that, you know, you yourself will even be proud of yourself when you get yourself in the forefront of those technology and become a subject matter expert, maybe later down the line. At least get on board. We don't want to be behind. We're all young, and there is a lot of opportunities, and the future ahead of us is still us working for another 20 years or so. And Industry 4.0 is going to be here for 50 years. So if it's starting now, we need to get on board so that we can be the ones leading this technology throughout our entire career working. And you can also work for yourself. That part I really do love. Again, thank you for being here with us. We hopefully will send out slides, and If Johnson permit us, we'll send out his material as well. And I'm thinking about maybe I should release this because only 18 of you are here, right? I would like to give this 18 my slides, not the remaining people who are now on the mailing list who did not come. So I'll think about it. Well, nice talk, nice time today. I really do hope this helped. Enjoy the rest of your evening, and hopefully we'll see you again next week. Take care.